On this first video, I will present the reality regarding the motion of light. I will explain why there is anisotropy of the motion of light relative to its source, and you will see why this leads to the detection of differences in the energy of the photons. This means that you will see that special relativity and general relativity are wrong. Something that is extremely important for our understanding is this. The motion of objects consisted of protons, neutrons and electrons is affected by the motion of the source of the object. But this is not happening regarding light. The motion of light is not affected by the motion of the source at the moment of the emission of light. The humans are stationary relative to the ground, the trees, the house, and also our source is stationary. And it produces a wave of light. You can say it photon, you can say it light. So this source, which is stationary relative to the humans, the ground, the houses, the trees, produces a light with a direction towards the humans. And we have this wave is moving towards the humans. We have found that from the one human to the other human, it makes, for example, one second to go this wave of light, to go from the one human to the other human. Now, if the source is on the move relative to the humans, we have found that the light wave that the source will produce, it will move again at the same time from the one human to the other human. Nothing will change. Meaning that the motion of light is not affected by the motion of the source at the moment of the emission and makes exactly the same motion. Let's see something else that will help us to understand what I'm saying. We have one source stationary and another source on the move. Now this source is on the move towards this direction. And when the source will be next to this source, both sources will emit a light wave towards the humans. So this source, the black source, will emit the black wave, but also this source will emit a wave. It will be a red wave. Now, as we have seen, the two waves will move exactly the same, regardless of the motion of the source. Because this source was moving towards this direction, when it is here, both sources will emit a light wave towards the two humans, but this source will keep moving towards this direction. So as the two waves are moving, are emitted by the sources and are moving towards this direction, this source is also moving towards this direction. The two sources were next to each other when they emitted the light, but they will not continue to be next to each other because this source will move towards the two humans. But the two waves of the two sources will make exactly the same motion, like the two waves will be like it if they are stationary relative to each other. We make the same motion and we move from the one human to the other together as a pair, for example. This is something that we will use, the motion of the sources relative to each other and the motion of the waves, which are exactly the same. We will use it to understand what is happening regarding the motion of light. Now, let's see the most significant realization that will help us understand the reality regarding the motion of light and why special and general relativity are wrong. Suppose that there are two sources of light moving towards each other. The blue source and the red source. They can be anywhere in our universe. It doesn't matter if they are on a planet like the Earth or on a different galaxy or between galaxies. It doesn't matter where they are. Each source is in an inertial reference frame, so no acceleration for each source. And they are in relative motion with each other at constant relative speed. And they are moving towards each other. The red source and the blue source. At some point, these sources are next to each other. Are next to each other, but of course their motion relative to each other continues. In that the red source will continue to move towards this direction and the blue source towards the other direction. When they are next to each other, both sources will emit the light towards all directions, meaning that while the two sources are approaching each other, they were not emitting light, but when they are next to each other, both sources will emit light towards all directions. From each source, we'll have the creation of one wave of light which is going to expand in space towards all directions. And we will have the following situation. These are not perfect circles, but I cannot draw here perfect circles. So let's slightly improve this circle. From here, let's see what goes here. When these two light sources are next to each other, each source will emit a wave of light. The blue source will emit the blue light wave and the red source the red light wave. But after the emission of the light, the sources will continue to move away from each other because they were going towards each other. When they are next to each other, they will emit light, but afterwards they continue to move. So this source will continue to move towards this direction, the red source, and the blue source towards this direction. So when they are next to each other, we have the emission of light, and two waves of light will expand away from the sources of light, will expand in space. Those two waves of light will have identical motion in space, because as we know, photons are making the same motion regardless of the motion of their source. So the photons that consist these two waves of light will make identical motion. The photons from the blue source and the photons from the red source will make identical motion, and we will have two identical circles, two identical waves of light expanding in space in exactly the same way. And as the two waves of light will expand in space in exactly the same way, next to each other, in exactly the same way, having exactly the same dimensions, those two sources will be moving away from each other. So as these waves expand, and for example they are in these dimensions, those two sources will not be next to each other. And there are two possibilities. One possibility is that both sources will not be at the hypothetical center of the wave, of the light wave that they are creating, which means in a situation like this, where the blue source is not at the hypothetical center, which is around here, and the red source is not at the hypothetical center of the red light wave. And the other possibility is that only one of the two sources can be at the hypothetical center. Either the red will be at the hypothetical center of its own light wave and the blue will not be, or the blue will be at the hypothetical center of its own light wave and the red will not be. The possibility for both light sources to remain at the hypothetical center of the light wave that they have created does not exist. This possibility does not exist. And the one possibility where the one source, for example, the red source remains at the center of its own light wave, we have in this situation isotropy of the motion of the light that the red source emits relative to its own source, but we have anisotropy of the motion of light that the blue source has emit relative to the blue source. So in this situation we have anisotropy of the motion of light of the blue wave relative to its own source. And we have isotropy of the motion of light for the red source. This is the one possibility, and the other possibility is that for both, in the possibility where both light sources are not at the hypothetical center of the light wave that they have emitted, in this situation we have anisotropy of the motion of light for both light sources. Anisotropy of the motion of light that each source has emit. I'm not talking about the motion of light relative to something else. I'm talking about the motion of light relative to its own source. The possibility for both sources to remain at the center of its own light wave as the light wave expands does not exist. Does not exist for both sources to be at the center, because as the two waves of light expand in space in exactly the same way, having exactly the same dimensions, those two light sources will move away from each other. They were next to each other when they emitted the light, but after that they are moving away from each other, and the one source is going towards this direction and the other towards this direction. Next, I will show you another example where will help you understand that the majority of light sources on the universe do not remain at the hypothetical center of the light wave that they have created. Let's say that we don't have only two sources of light, but we have much more light sources. 10, 100, 1,000, a million light sources, not at different locations, at close locations, for example, at the surface or at the atmosphere of the Earth. Or, for example, somewhere between the Earth and the Moon, or somewhere in our solar system, but the sources are not for example, the one source at the Earth and the other source at the planet Mars. No. I'm talking about situations where the sources are at the same location, close to each other, and they are under the same gravity, which is the gravity at this place. And I will create here an example with 6 sources of light, because I cannot create here an example with 1,000,000 sources or 1,000 sources or even 100 sources. I will create an example with 6 sources of light. And we have here 6 magnets, 2 blue, 2 red, 2 black. Let's say we have 6 small light bulbs that are moving towards each other. All these 6 light bulbs are at an inertial reference frame. They are not under acceleration. But each light source is in a relative motion with the other with the other 5 light sources at constant speed with every light source, because each light source is in an inertial reference frame, not under acceleration. And they are coming and they are going towards 2 opposite directions. And we have, for example, the black source. One black source is moving towards this direction and the other towards this direction. The blue here, the red from there. So 3 are going from this direction towards the other 3, and the other 3 towards this direction towards the other 3. They are not having the same relative speed with each other. For example, this red source doesn't have the same speed, the same relative speed with all the 5 other sources. It has a different speed with this one, different speed with this one, different with this one, different with this one. This is happening for all light sources, but they are moving towards each other. at some point we have a situation where these 6 sources of light are next to each other, like this, like we have in the previous situation where we only have 2, when we only have 2 sources of light. But now we have 6, and you can imagine that we can have a million light sources. For example, between the moon and the earth, moon, earth, and these sources, they will meet between the earth and the moon, and they are moving some towards this direction and some other towards this direction. This situation, it is between the moon and the earth, or you can imagine that it is on the surface of the earth, or on the atmosphere of the earth. So we have the 6 sources of light that were moving towards each other. At some point they are next to each other like this, in line like this. And when they are like this, like in the previous situation, there will be emission of light wave from all 6 sources. Each source will emit light towards all directions, and a wave of light will be created by each of the 6 sources. And we will have 6 light waves expanding exactly in the same way in space. And this can happen anywhere. It's happening on the planet Mars, on the planet Jupiter, somewhere in our solar system away from a planet, far away from our solar system, between galaxies. It doesn't matter where it is happening. 6 waves of light, each light wave created by each of the sources, and these 6 light waves will expand in exactly the same way, because the photons are moving exactly the same way, making the exact same motion regardless of the motion of their source. And we will have 6 identical light waves expanding away from the sources. We will have 6 identical waves of light expanding away from the sources, like I have shown to you on the previous example where we only have 2 sources of light. But I will not draw here 6 light waves on the board, because we will not be able to understand what I'm showing here. So I will create only the part of the waves towards this direction and this direction. You can imagine a circle from created a light wave from each source, but I will not create a circle. I will create only the parts of the wave here and here from each source, the light wave from each source. These 6 were next to each other when they emitted the light, but they are in relative motion with each other. So after the emission of the light, they will continue their motion, their relative motion, and 3 are moving towards this direction and the other 3 towards this direction relative to each other. Let's first draw the waves of light, and then we'll show the motion of the sources. So we have expanding light waves from each light source, and we will have here from the blue source, and here from the blue source, here from the black source, and here from the black source, here from the red source. I have created here only the parts of the wave towards this direction and towards this direction, but imagine that it is a circular light wave created by its source of light. The light from all the sources will make exactly the same motion, because the motion of light is not affected, is not influenced by the motion of the source at the moment of the emission. So we'll have all the light created by all the sources emitted towards this direction, making the exact same motion, and all the light towards this direction making the exact same motion. All the light from all the sources making the exact same motion, moving away from the sources, the sources in space in exactly the same motion. But these 6 sources were next to each other when they emitted the light. After the emission, they will move away from each other because they are in relative motion with each other. And we can have, for example, this source to be here, this source here, this here, this here, here, and here. They were next to each other, the sources, when they emitted the light, but after the emission, they are in relative motion with each other, and they continue the relative motion, and the sources are moving away from each other. And like in the previous example where we have only 2 sources, there are 2 possibilities. One possibility, all 6 sources will not be at the hypothetical center of the wave of light that they have emitted, or only one of the 6 sources can be at the center. For example, this blue light source, if it is at the hypothetical center of its own light wave, the other 5 cannot be, because they are in relative motion with this light source. This is the one possibility where only the one of the 6 sources can be at the center, and the other 5 cannot be at the center of the wave that they have emitted because they are in relative motion with this blue source. And the other possibility is that all the sources, all 6 sources, will not be at the hypothetical center of the light wave that they have emitted. The possibility for all 6 sources to remain at the center of the light wave that they have emitted, this possibility does not exist. And we can have 100 sources or 1,000,000 sources. If we have 1,000,000 light sources, either all of them, all 1,000,000 sources are not at the hypothetical center of the light wave that they have emitted, or only one of the 1,000,000 light sources can be at the center of the light wave that it has emitted. The possibility for all the sources to be at the center does not exist. And from this we can understand that general and special relativity are wrong, and the idea that the scientific community has about the motion of light is wrong. Because when a light source does not stay at the hypothetical center of the wave of light that it has created, means that towards different directions we have different motion of light relative to the source, not relative to something else. Relative to the source that it has emitted the light. Because if the source is here at the center, Isotropy means we have towards all directions, the same motion, but if we have this situation where the source is not at the center, it means that towards different directions we have different motion. Because when we talk about isotropy and anisotropy, we talk about differences dependent on direction. And in this situation, where the source remains at the center of the wave of light, means that the photons that are at the wavefront have the same motion relative to the source. But if the source does not, means that the photon, for example, that it is here, has different motion than the photon that it is here. Different motion relative to the source, not relative to something else. Different motion relative to the source. And you will see on the television, on the internet, on a book, when the scientific community wants to show us a source of light or a source of electromagnetic radiation, regardless if it is stationary on the surface of the earth or it is away from the earth in the open space, they always place the source at the hypothetical center of the waves of light, that this source, whether it is source of light or in general electromagnetic radiation, they always place this source like this. They always put the source at the center of the light waves that it emits towards all directions, but this is wrong. This is wrong. The reality is that this is wrong. The reality is that the majority of light sources on the universe, they are not located at the hypothetical center of the light wave that they are emitting towards all directions. And I'm talking, when, for example, I have shown you this example, I'm talking about sources next to each other at the same location. I'm not talking about sources, one, for example, here on the planet, and another source on another planet, another source on a different planet, because we can have a source on the earth that can be at the center of its own light wave. We can have another source at the planet Mars, which also can be at the center of the light wave that it has emitted. And we can have another source on the planet Venus, that it also can be at the center of the light wave that it has emitted. And we can also have another source in our solar system away from a planet, but it can also be at the hypothetical center of the light wave that it has created. Because we are talking about different locations, and in different locations we have different influence from gravity, because on the planet Earth we have influence from the Earth's gravity. On the planet Mars we have a different influence from the gravity of the planet Mars, or away from a planet in our solar system we have influence of the gravity in this specific location. Because we can have away from a planet, for example, somewhere in our solar system, away from a planet, a source of light to be located at the hypothetical center of the light wave that it has emitted. But if we have another million light sources next to this source in this location, next to this source in relative motion with this source, all these other 1 million sources will not be at the critical center of the light wave that they have emitted. Because the motion of light, it is affected by the gravity, on the place, on the location that the source is and the light is. It is affected, and it is not affected in the way that the scientific community thinks. Because the scientific community thinks that the motion of light is always the same, the motion of light or the speed is always the same, and we have differences in the energy that we detect on photons, not because the motion of light is different, but because of other things. And I'm talking about photons, I'm talking about identical photons which are supposed to have identical energy. But we found that even though a source has emit identical photons towards all directions, we found towards different directions photons having different energy. They are having different energy because relative to its source don't have the same speed, don't have the same motion, and so the same speed relative to its source, but also relative to a detector that it is stationary relative to the source. And it is not happening what the scientific community thinks that is happening, which is that the motion of light, the speed of light is always the same, but we found differences on the energy of the photons for other reasons, because they think that the motion of light is always the same. The motion of light is always the same, but is always the same in space, in a specific location. The motion of any photon is the same, regardless of the motion of the source, but this is totally different when we talk about the motion of the photon relative to its own source. The motion of each photon in a specific location is the same regardless of the motion of the source, but it is not the same the motion of all the photons relative to the source.